In this video, we're going to have a brief discussion about concavity and what it tells us about functions. So we say a function is concave up if as you move left to right, the graph is bent upwards, and concave down if as you move left to right, the graph is bent downwards. So we are always working left to right. So let's look at some examples of concavity and how it actually affects what's going on with the function. So the first one we're going to discuss is what it looks like if something's concave up and increasing. If a graph was concave up and increasing, it will take this shape on here. And so the reason I'm saying concave up means bent upwards, notice as you move left to right, this graph faces up. And so there's something that's interesting that's happening here. Since this graph is concave up and increasing, if I was to think about like the slope or the average rate of change at this point, it would have just kind of like a slight positive slope. But if I pick this point here, it's still a positive slope, but notice now that it's steeper. So the concavity, the fact that it's concave up and it's increasing, the concavity actually speeds up the rate of the increasing. Now let's look at what happens when a function's concave up and decreasing. It'll have a shape similar to this. So again, notice this graph is facing upwards, and that's what we mean by the concavity. That's facing upwards as you move left to right. Well, let's say I pick this point here. At this point here, we have a very negative slope. But as I move further down, if I were to pick this point here, the slope is still negative, but it's not as strong, it's not as steep. So the concavity, the concave up factor, decreases how fast the decreasing is actually happening. It's slowing down the amount that we're decreasing by. Alright, so now let's explore concave down and see what that looks like. A graph that's concave down and increasing will take on a shape similar to this. And we're saying it's concave down because it's facing down. Now if we look at this graph, if I pick like say this point here, we have a very strong positive slope. But as I move further along, the concavity, the fact that it's concave down, slows down the rate of increasing because now this graph doesn't have quite as positive of a slope. It's not as steep. A graph that's concave down and decreasing will have a shape similar to this. And so if we look at this graph, and I picked like this point here, the decreasing causes the negative slope. And then in addition, the concave down causes that rate of decreasing to actually speed up. We actually get an even more negative slope as we move further along the graph. So in this problem, we're going to look at an application, see how this rate of change deals specifically with concavity. So a grapefruit is thrown up into the air, and its height in feet is given in the table below. So what you'll notice is during this time here, from 1 to 3, the grape is going upwards, right? Its height is 6, 90, 142, 162. And as we move along, during this time, it looks like it changes directions and starts coming down. So let's compute the average rate of change from t equals 0 to t equals 3. So as we discussed previously, that's the change in the outputs. So 162 minus 6 over the change in the inputs, 3 minus 0. That would be 156 over 6, which is 52. And it's always output per input, so feet per second. meaning from 0 to 3 seconds, this grapefruit is traveling upwards at an average of 52 feet per second. Now let's look at the average rate of change from 3 to 6 seconds. The change in the outputs, 30 minus 162 over the change in the inputs. That would give us negative 132 over 3 equals negative 44 feet per second. And so it makes sense that we get a negative slope here. Why? Well, as we discussed in this red section up here, this is the time when the grapefruit is falling back down, so its height would be decreasing. So let's think then about the concavity. Let's first consider what this graph would look like. We know our input is time, and specifically we're in seconds. And our output is height in feet. And at 3 seconds, we're going to experience this change where it starts to come back. So we're going to look at from 0 to 6, let's say. Okay? At 0 seconds, we're just a little bit off the ground, 6 feet. And then until we reach 3 seconds, we know the height of that grapefruit is increasing. But when we get to 3 seconds and onward, the height begins to decrease and comes back towards the ground. And so we can see now, clearly this is concave down. And specifically what causes that is actually the fact that the rate of change is decreasing. It went from positive to negative, and we're going to discuss that further in the future.